All right, so for today we're actually starting trigonometry. We're going to go through and do a lot of identification of these triangles. Understand that by similarity, side ratios in right triangles are properties of the angles in the triangles, leading to definitions of trigonomic ratios for acute angles. Now, I just said a whole lot. I'm going to explain it. It's not going to be that bad. Okay, if two angles and two triangles are congruent, kind of like this, I got this one congruent to this one, and I have this one congruent to this one, these two triangles are going to be what?
Congruent.
Not congruent.
Similar.
Similar, that's the word I'm looking for. This is going to be similar. So they're going to be similar to each other. Alright, so if angle A is congruent to angle D, that's what I have here. C is congruent to F, that's what I have there. What do we know about the third angle of the two triangles? Okay, let's do the math. If that's 30, that's 90. This other one has to be 60. Very good. If this is 30, that's 90. This other one has to be. Then I know that the third angles are. They are going to be 60, but if they're both the same, what's the word I use for it? Congruent, right? So the third angles are congruent. Okay, so angle A is 30, C is 90. What's the measure of the third angle? We already said that. 60 degrees. If one angle is 90, the other two angles have together add up to how much? All of them add up to 180, right? All of them add up to 180, but if one of them is 90, the other two have to add up to 90. So let's look at it right here. So we said if this one is 90, these two together have to add up to 90. So what is it called if the angles add up to 90? I heard it. Complementary. Complementary. Alright, so find the complement of angle A if angle A is 20. What does the complement mean? They together have to add up to? Complement is 90. Complement is 90. So if this one is 20, the other one has to be 70. Thank you. Hopefully I'm not actually confusing anyone yet. A lot of them, all these are going to be 90. Okay? If two triangles are similar, then the sides are... No. If the two, what do we know about the sides? If they're similar, they have the same... Ratio. What's another word that we use? Scale factor, or a third, starts with P, ends in ortional? Proportional, right? They are proportional, which means the same thing. They are proportional to each other. Okay? So same scale factor, right? Alright, same scale factor. For triangle ABC, that's this one right here. For triangle ABC, what is the ratio of the short leg to the hypotenuse? Now, in this one right here, which one's going to be the short leg?
D.
Okay, so right here, ABC. Now, I don't know if you guys actually learned this ever before. In a triangle, the largest angle is across to the largest side. So let's think about it. This is 90, right? So the longest side is going to be little c, right? So we said that angle B over here was how much? 60. We said it's 60. So that means that the smallest side would be little a, wouldn't it? Because it's the smallest angle. So the smallest angle is across from the smallest side. So right here, ratio of the short leg to the hypotenuse. So my short leg is going to be this one right here, which is BC. So it's my BC over, what is my hypotenuse? BA or AB, right? Okay, which would be the same as saying little a over little c. Does that make sense or no? Are you guys okay? The shortest side goes with the shortest angle. The largest side goes with the largest angle. What is the ratio of the long leg to the hypotenuse? Now, which one's the long leg now?
AC.
AC. So AC and my hypotenuse? AB. The hypotenuse is always across from my right angle. So that one's going to be the hypotenuse always. So I would rewrite that as, it's going to be B over C. B over C, because this one right here, right? My AC. What is the ratio of the short leg to the long leg? The short leg was BC. Long leg? AC. And I would write that also as A over B. Now, we're going to start referring to these. Okay? New way to refer to the sides of a triangle. So now we're going to refer to them according to where they're at. So if I'm starting right here, this is my angle of reference. Okay? Use angle theta as your reference angle. Okay? Greek letter theta. So it's a circle with the line through it. So this is theta. That's my angle of reference. This little box signifies that that is my right angle, right? So across from my right angle is going to be my hypotenuse, right? So I'm going to actually write, so it's going to be directly across from the right angle. All right, so now let's take a look at the next one. So the opposite side, okay, so this refers to my angle. Okay, if my angle is my starting point right here, my angle theta, opposite is going to be this way. I cannot do a reference until I get a starting point. So this is my reference angle. Across from that is going to be opposite. Okay, so we draw a line. Directly. From reference angle. So we have that there. So there's my reference angle going directly across. So this thing is going to be my opposite. So I'm going to refer to it as the opposite. This side is going to be always referred to as the hypotenuse. The last one is going to be my adjacent side. My adjacent side, I'm going to say that that is going to be next to. So that is next to my reference angle. So if this is my reference angle, there's my side that is next to it. These other ones are referring to all the way across. So opposite that. So opposite the right angle is my hypotenuse. Opposite my reference angle is my opposite side. And my third side is going to be my adjacent. Alright, so let's take a look at this next one over here. So now, for angle A, so now A is my reference angle here. That's important. So I'm actually going to change it down here. For angle A, the ratio of opposite to adjacent. So if I'm starting here, this is my reference angle. If this is a reference angle, okay, which one is opposite little a, right? Very good. So it's going to be little a over. Which one is adjacent to little a?
B.
Little b.
No. What is little b?
Oh, little c.
Little b is the hypotenuse, so it can't be the adjacent. So this one's a hypotenuse, so the adjacent has to be
C.
C. There we go. Now, for angle A again, adjacent. So we said adjacent, so from this angle right here, the adjacent is
Little c.
little c, very good. So it's little c. And the hypotenuse,
Little b.
little b. So the hypotenuse never changes because it's always going to be across from the right angle. Now, for A, again, so starting there, opposite. What is opposite A? Little a over the adjacent is little c, right? Now, this time I'm changing my reference angle. My reference angle is now starting over here. So from this angle right here, what is opposite of this angle? C, very good. So little c over adjacent. What is adjacent to C?
Little a.
Little a, very good. From C again, what is opposite C? Little c. And the hypotenuse? Little b. The hypotenuse never changes because it's always across from the right angle. And my last one right here, from C, okay, what is adjacent to C? Little a over the hypotenuse? Little b. Was that so bad? No, it's not. So that's basically what we're doing. We're identifying our sides. Okay, so we're just referring to them by their sides. And now you guys, for your practice, which is page, what's this, 28? Yeah, this one's going to be on 28 now. Okay, so now let's take a look. So you guys are going to mark the sides right here. Okay, opposite leg to angle A. What is opposite to angle A? CB, very good. You guys can fill these in. All right, let's look at the next part. Now, complement means it adds up to
90.
90. Class,
Is
complement adds up to
90.
class. What does complement add to?
90.
So I'm going to put a 90 right here so you do not forget. Class,
Yes.
what does supplement add up to?
180.
Okay, so you guys got this? All right, good. Get her done.